Okay, now that we have Cutter installed, let's take a look at this lab. So the first thing we're going to do is create a working folder in a file named safesample.c. So we're going to run make dir, and I've actually uh, am able to just quickly type Cutter Lab because it was done before. So make dir space dash p, and then we're going to create the Cutter Lab directory. And this tilde right there is a shortcut for this particular directory. So, and actually, before we do that, let's do ls to take a look at our current directories. Okay, so as I said, we're going to do make dir and dash p and then tilde Cutter Lab. All right, and we're going to press enter, and then let's do ls again, and we do have the Cutter Lab that we have created right here. So the next thing we do, let me roll this lab over. Sorry about this. Let me put this over. So cd, and then we're going to change directory into the Cutter Lab. And then we're going to, the lab says use nano safesample.c. We're going to use Vim because I think I like Vim better. I don't know why. Anyways, we have changed directory to the Cutter Lab. And just so you know, just to verify, if we do present working directory or PWD, we're in my home directory. Okay, so we're going to change directory to the Cutter Lab, and that's what we did. Now, if we do present working directory, we can see that we are in fact in the Cutter Lab. Now, according to the lab, we are then going to do create the file for safe sample, and we'll do that. But at the same time, we will let's see, we'll also copy and paste the entire program in, and let me see if I can make it shrink this a little bit, and so this way I can bring this up here. So the next thing we're going to do, we're going to copy and paste the code after into the safesample.c. So let's do that right now. So we're going to say vim safesample.c, press enter. Now when we get into a Vim file, we can't just start typing away. We have to get into the input mode. So we type in I for did I say input? I meant insert. So all I have to do is copy and paste the code right here because this is not a C class on C. So I'm just going to do Control C, and I'm going to do Shift Control V for paste so I can paste it in. And we want to make sure, in fact, we have everything copied and pasted in here correctly. Now in our Vim file, we're going to press Escape, :WQ for write quit. All right, and then according to this lab, we're going to compile and run it. So GCC will compile this C folder into zeros and ones, and then period forward slash safe sample will actually run the safesample.c. Okay, so actually, I'm going to be real lazy, and I'm just going to copy this, Control C. When I say Control C, I'm on the Mac, I meant Command C. Command C copies. And then we do Shift Control V, and this will compile the safe sample. So let's do a list, and we can see that we initially wrote safesample.c, which is what we would consider source code, and then safesample is the program that is the result of the compiling the compiling of safesample.c. The next thing we're going to do is we're going to run safesample. So we can do period front slash safesample, and we're going to do enter. And it just says hello from a safe program. This lab practices reverse engineering basics. Now here's the strings that we did: API check-in, user agent, lab client 1.0, and token equals demo token. So now we're going to open it in Cutter. Okay, so we're going to just type in CUTTER for Cutter. And we're going to select new file. And then we're going to open. Now, do not open the .c file because that kind of removes the purpose. The reason why we don't care about reverse engineering the .c file is because the idea of malware is we're not going to have the source code. So we're not exactly sure, how it does what it does. We only see the effect. So what we want to disassemble, if we want to be as realistic as possible, is the actual executable program. So that's where we're at right now. Safe sample. We're going to go to open. Okay, and then we can go to open here. And actually, my apologies, the execution button is all the way on the bottom. I wish, oh darn it, I wish this thing was a little bit, see if okay, here we go. I was hoping I could bring this up. I am sorry. Oh, here we go. It is not allowing me to, so just so you know, under advanced options, all the way down here, there's an OK. All the way down here. So it's at the bottom right hand of this box. And unfortunately, I am not, the recording window is below. I wish I could change the recording window. Anyways, you're going to type in OK. And this is Cutter. This is Cutter right here. Okay. Now let me get back. Hopefully everyone sees this. Now we're going to answer the questions. Identify file details. Okay, write down file format. Okay, so let's see. Let's take a look at this. Okay, this is the dashboard. Okay, now we want to click on dashboard to start. Now the file format is ELF. Okay, now what else is it? Architecture. Architecture is right here. Mine is ARM. Okay, yours might be x86 64. Entry point address and hex base address is here. There's also the entry point here. And that is the offset here. Is it stripped or not? Let's take a look. Stripped is false. All right. Let's take a look. Find... Sorry. Just have a bad cough. So we want to find the main function. Open functions list, which is this. Here's the functions list. Okay. And here's another entry right here. Here's another offset right here, 6C0. Okay, so you can choose any one of those. Now, let's see. Find the main function. That's this right here. Click on it. This is the main function. Okay. And open the functions list and locate main. Click it to view the disassembly decompiler. That's exactly what we did. Right here. Let's see. Strings view. Open the strings view and locate the indicator example strings. So the strings view is right here. Okay. And we are looking for right here the indicator strings. Double click on it. Okay. And you can see all three right here. Boom, boom, boom. So indicator example string only, API check-in, user agent, and token equals demo token. So those are the strings. Open the imports view and identify any imported functions. So the imports view is right here, this tab. And then here's the functions. So we looks like we have libc start main, abort, puts, and then there's cxa finalize. Okay, and so here is the report that you can write. And why do the strings look suspicious, but why is the program still harmless? Okay, so you can work on that, and that should be enough to at least get everyone started. Thank you.